Hello, everybody. Hey, this is going to be a review of question of the day 4.6. So question of the day 4.6 was a conservation of momentum problem. So we've got two skaters. We've got Mike and Millie. Sorry. Mike and Millie. Okay, so they have an initial velocity that's equal to 8 meters per second. Okay, so the first question in this question says, what is the momentum of Mike beforehand? So momentum is going to equal to M1 V1. And this is going to be, the mass of Mike is 90 kilograms. So we've got 90, and Millie was 60 kilograms. And so we're going to have 90 times 8. And I believe that was, in fact, 8.0 meters per second. And therefore, we're going to get 720 kilogram meters per second. That is going to be the initial momentum of Mike. And in a similar fashion, we're going to get the initial momentum of Millie, which is going to be 60 also times 8.0, which is going to give us 480 kilogram meters per second. And as a note, that is going to give us 1,200 kilogram meters per second, which is going to be our total momentum before. Okay, so that is going to be part A and part B. And now question C is asking us, what is the momentum of Mike after the push? Now, this is going to be a conservation of momentum problem. So we're going to have M1 V1 plus M2 V2 is equal to M1 V1 final plus M2 V2 final. Okay, so we know that this right here is 1,200. Okay, and we know the mass of Mike is going to be 90, and that's going to be V1 final plus 60. And after they push off, Millie's velocity, V2 final, is going to be 10. So that's going to be 10. So we can obviously see here that this is 600 and this is 1,200. This is essentially becomes our unknown, which I suppose would be P. And we're going to get 1,200 minus 600, which is going to be 600, which is going to be the final velocity, the final momentum for Mike. And then what is the momentum of Millie after the push? Well, we know that that would be 60 times 10, because they give us the final velocity. All right, so here's that, and here's that. All right, so now we get part E. It says, what physical concept allows you or us to make this calculation? And that is just conservation of momentum. That's all it is. So momentum before is equal to momentum after. And then finally, F, what energy did Mike exert? That'd be converting chemical energy in pushing off Millie. So as we have known before, that work is energy, and energy or work is equal to the change in kinetic energy. So we can say that kinetic energy final minus kinetic energy initial is going to give us the amount of work. So that's going to be 1/2 M1 V1 final squared plus 1/2 M2 V2 final squared. And that's going to be minus 1/2 m1 plus m2 v initial squared, because initially they are together. Now, in order for us to determine this, we need to know what the final velocity, what is the final velocity of Mike? And so we're going to go right here. So we know that 600 is going to be equal to 90 times v final. 90 times v final. Okay, 600 divided by 90, that's going to be 6.67, 6.666. We could call that 6.7 meters per second, rounding to the correct number of significant digits. So now we can say 1/2 of 90 times 6.7 squared plus 1/2 of 60 times 10 squared, okay, minus 1/2. Their masses together are 150, and their initial velocity was 8. And now, if we calculate that up, that's going to be 2,000 plus 1,080 minus 4,800. And that is going to give us the change in kinetic energy that is equal to 1,720 joules. And when we round to 2 significant digits, we're going to get 1,700 joules. So that's a change in kinetic energy. And that is our question of the day for 4-6.